Hi all, welcome to this tutorial. In this tutorial, I'm going to tell how to create a simple system using Cyclone 4 FPGA. In Cyclone 4, we are going to target a Nios II software processor, and then we are going to communicate to the processor, and then we'll be displaying a string to the console back. So to create the system, we need to do hardware as well as software part. So first, we'll take the hardware part, and I'll explain how to do that. First, go to File, New Project Wizard. In this project wizard window, we are going to create a project name and we are going to give the target directory, and we are going to choose the target device family and the device detail. So I'm going to create a directory here. The name that I given is hello. So throughout the hardware part, I'm going to use the same name. So do you want to create it? Yes. So the directory hello will be created now. So the project type is by default empty project. Click next. I don't have any existing file. I'm going to create a system freshly. So you can skip this step 2. Now this is a very important part where we are going to choose the target device family, which is Cyclone 4E, and you have to choose specific device selected in the available device list, that is a target device. And what we have here is EP4CE115F29C7. It's very difficult. We have a lot of device. So to shortlist, you can use this option, package FPGA, and pin count 780 and speed grid is 7. So now we can see the last but one, EP4CE115F29C7. So choose this device and give next. So we are not going to have any other EDA tools, so just give next and finish. So now you can see the project has been created, the name hello. So to begin the hardware part, we had to invoke platform designer, go to tools and platform designer. So now you can see in the system contents, we have a global clock, and in the system content tab only, we are going to add the required hardware over here. So how to add those hardwares here? Here you can able to see on the left hand side under the IP catalog. So we'll be searching whatever the hardware component required for our system. So as I told earlier, for this system, we need a Nios II software processor and an on-chip memory and a JTAG to communicate to the processor. So first I'm going to add the Nios II processor. So here you can able to see. So Nios II, there are two versions. One is a classic or other one is a Gen 2 processor. You can choose anything. So now I'm choosing Nios II processor here and then add. So once you add this, so you'll be getting a pop-up window here and you have to choose the core, Nios II software that you want to choose, either in economic mode or in the fast mode. So economy mode, your area will be less, performance will be moderate, fast area will be moved, and performance also will be better. So for this simple system, I'm just going to use Nios II economy. Okay, then click finish. Now next I'm going to add on chip memory. So here you can able to see on chip RAM or ROM. Just click add. Now the Cycloid 4 FPGA has both internal RAM as well as ROM. In this case we are going to use RAM, and maximum it has 414 KBs. So I'll be giving 400 KB. Just give finish. We have added an on-chip memory. Then JTAG. So here under the interface protocol, serial protocol, we have JTAG UART. Just add. So no other changes required. Just give finish. Now we added the required hardware components to make this system. Now we need to connect them all. So first the global clock. Here you can see connect all the global clock. Then reset. Right. Then from the data master to both on-chip memory and to the JTAG. Then from the instruction master to the on-chip memory alone. Then internal resets from the processor. Right. So once this is done, we have to give the vectors. There are two vectors. One is reset vector and exception vector. So you can double click on this Nios II processor. You'll be getting this pop-up window and choose the vector, and now choose on-chip memory. Fine. Then we had to give interrupt request. So by double clicking you can enable this option, and you can see the clock is a global port, that is under the export you can able to see clock and reset. So once these connections are done, we have to assign base address. For that, go to system and then assign base address. Fine. So now we have connected all the systems perfectly. So you can see no error message. So once this is done, we have to generate the HDL. To do that, go to generate HDL. And here you can able to see synthesis. Synthesis files are used to compile the system project in quarters. So this will generate a Verilog, whether you want VHDL or Verilog. So by default, we're going to choose Verilog. And the path you can see here. So where we have created, right? And before that, you should save this system, what we have created. So first, file, save. So you can use the same name as we created, hello.qsys. It's done. Now go to generate HDL. So this is a path where it's going to save the Verilog file. Just click generate. Now it's generated successfully. Just close this. Now come back to Quartus Prime. Now we have to add those HTML file to this project. So how to add it? So by right clicking here onto the device, you get settings, or you can go to assignments and then settings. Now under this file tab, you can browse to the location hello and then synthesis. Choose all file. You can find there are two files. One is .v and then IP variation file. So choose these two files. Open. Arrange the order. First will be the IP variation file, then Verilog file. So this will be the hierarchy. Then apply. Then click OK. So now you can see those under the file section. By double clicking, you can see that. So please ensure that the module name and the project name are same, right? That's why we use the same name in Traces too. So now we have got the code. As usual, we'll follow the hardware implementation flow. So first step, go to processing, start compilation. So meanwhile, we can start the software flow also. Come back to quizzes, go to tools, and Nios II software build tools for Eclipse. So very important step here is the workspace. So whatever the project directory that you created, so you have to give that location. So every time kindly ensure this. So hello, right? So this is the project directory. Just give OK. Right? So Nios II Eclipse has been invoked, right? Fine. So come back to Quartus Prime. Let us see the status still running. Okay. Meanwhile, again, we'll do the software flow. So now we are going to create a new file, that is Nios II application. And board support package BS, which stands for board support package from template. Just click on this. So you'll be getting a pop-up window where we need to specify SOPC info file. So which is called system on programmable chip file. We'll be getting this file once you generate the HTML code in Cohesys environment. It will be saved into the same directory. Browse to that location. So here you can see that, right? Choose and give open. So it has taken the CPU name from this SOPC info, right? Now just give the project name, same name, right? And the template by default, hello world, just give finish. So now you can see VSP directory and the project directory has been created. Fine. Now we'll come back to Quartus Prime environment. Now the successfully compiled. We have to make a HIVO assignment. Assignment, import assignment. D2115, right? So just give OK. Go to assignment and then assignment editor. So now you got the pins list here. Go to Verilog code. Now we can see there are two inputs, clock underscore clock and reset underscore reset underscore n. Now assign clock underscore clock to clock underscore 50 and key 0 with reset underscore reset underscore n, right? Save this, do compilation, processing, start compilation. Again come back to this Nios II Eclipse. So you can see here, this is a board support package. This is hardware acceleration loop directory. Anyhow, on the project directory, you can see the hello world.c file, right? Just double click on this. So you'll be getting the code here. So just tell that printing the value after contacting the processor, softcode processor in the FPGA. It will display that again back to the console queue. So now the compilation is successful. So next step, you have to download this SO file to the target hardware. The tools, programming. So ensure that your device is on. Now click onto the hardware setup and choose the USB blaster. Now you can see this SO file has been generated, right? Now just dump this, clicking start. So now the hardware part is completed. Coming to the software part. So just right click onto the Hello project. Now you can see there's an option called build project, right? Just click on this. So it's done. Last step, now we have to run as Nios II hardware. Okay. So again, we are going to use the same JTAG. Already we have created the hardware in FPGA. Now we are going to run the software onto the target hardware. So you can see the target connection, right? So just click refresh connection. So now it's been connected to the JTAG USB blaster, right? Apply, run. So you got a message, right? Hello from Nios II. So you can use this key 0 and you can see, right? Again, communication from the processor. Okay, fine. So this gives us an idea that how to create a simple system and how to communicate to the Nios II system. Thanks all. Yeah. Fine.